Well, I would say whoever shot these arrows is not a reliable performer in archery, right? We're going to be talking about test reliability. Making sure a test is reliable, whether it's a standardized test or a teacher-made test. Reliability is a measure of consistency, that you will always get the same result from this test. So it needs to be statistically proved when it comes to the standardized test. It has to be statistically proved that this test is reliable. And the way it's typically done is, at least one big method is, test retest. You give the test, you give the same people the same test, they should score almost exactly the same scores, right? They should, if the test is reliable. Another way to check for reliability is to give alternate or parallel versions of the test. Some people get version A, some people get version B, and you compare, and you've split the people into two groups very randomly, so you should get the same distribution of scores from A and B groups. Split halves. You divide people into odds and evens, give them the test, you check the reliability. Or in some very unusual cases, you have perhaps no way to give them alternate versions or something. You have to only give one test, and then you go find a statistical formula that will let you check reliability anyway, like the famous, or not so famous, Cooter-Richardson reliability statistical formula. And with just one test, you can still prove how reliable a test is. Don't worry about that. The main thing is that there has to be a way to check and see on any kind of test, is it consistently giving the same kinds of results, no matter who takes it, when they take it, or which version they take. But because we're dealing with comparing test A with test B, or taking it in the morning compared to taking it in the afternoon, we're always comparing two things, then what we're looking for in statistics here with reliability is what's known as correlation. Correlation means how closely do two things give you the same results. A perfect correlation in statistics is 1.0. That's perfect correlation. This goes up, second version also goes up, has the same results. In statistics, anything above 0.8 is considered okay. Okay, this is good enough reliability, usually if we can statistically prove that version A and version B have 0.8 correlation, then we say the two versions do have reliability. Well, just to look a little bit further into this whole idea of correlation, a 0 proves there is no correlation whatsoever. Okay, the number 0 says when this number goes up, this number could go anywhere. When these people took the test in the morning, they got this distribution of scores, and over here, when they took the same test again in the afternoon, some of them went up higher and some of them went up lower, and it was just crazy, and there's no correlation. That's a 0. It's possible to have negative values. A perfect negative correlation would be minus 1.0. As one factor goes up, the other one goes equally down. That's a good correlation if you're trying to prove that. Obviously, with testing, we're not usually doing that sort of thing. But there are times when we're trying to prove a negative correlation, or we're trying to measure a negative correlation. So it is possible to have a perfect 1.0 minus 1.0, and that actually really proves something. The one that doesn't prove anything is a 0, because there is no correlation there. Okay, a little bit of statistics, enough to give maybe only a little bit of a headache. Something you will want to look into more, especially though, when you're looking at teacher-made tests, to make sure your tests are reliable, that your students are getting, if they're getting version A or version B of the test, it wouldn't matter, they'd make the same score either way. First period class and seventh period class should have the same basic range of scores. So that's what reliability is all about, and you might want to do some more research on that and supplemental reading, review questions, and go through this video once or twice more and take some notes.